Hello my dear students, so how are you all? I hope you all are doing well. I am Bhagwanti K. Patel, your dedicated chemistry faculty committed to guide you and prepare you for your CET examination. So today we will be discussing about the home assignment question on some basic concepts of chemistry. So without any further wait, let us start solving all the questions quickly. So the question number 1 is, two oxides are there of a certain metal and were separated in a current by passing what? Hydrogen, until constant weight was obtained. So here we are getting a constant weight of your metal atom, because here water will be obtained, okay, because hydrogen and oxygen from your metal oxide will combine and will give you water. So this water is carefully collected, and for 1 gram of each oxide, if we take 1 gram of each oxide, how many grams of water we are getting? 0.2 grams of water in first case and 0.4 grams of water in second case. So what does it illustrates? So it can easily, you can say that if 2 oxides are present, it contains metal and oxygen. So there will be different ratio. So it will be law of multiple proportions simply. But if we want to calculate also the proportions, so you can easily do that. For first oxide, you can say that, so the weight of oxygen present will be, for first one, it will be 0.2 divided by 1 gram you have taken, and mass of oxygen is 16 and mass of water is 18. And in case of second one, it will be 0.4, they have said, mass of oxide is 1 and 16 divided by 18. So it will be simply giving you 0.2 is to 0.4 ratios, that means 1 is to 2. So therefore it is a simple multiple and hence law of multiple proportion. Next question. Statement 1. Number of moles of hydrogen in 2.24 liters of hydrogen is 0.1 mole, they are saying. So you know that 22.4 liter of hydrogen consists of 1 mole. Then 2.24 liters of hydrogen will consist of how many moles? It will be simply your 2.24 divided by 22.4. It will be giving rise to 10 raised to minus 1, which is equal to 0.1. Now statement 2 is saying 22.4 liters of hydrogen at STP contains 6.023 into 10 raised to 23 moles of your hydrogen. No, it consists of 23 molecules of your hydrogen, not the moles. So it is your wrong option. So therefore statement 1 is correct and statement 2 is incorrect. Next question. The number of molecules of water in 333 grams of your aluminium Al2SO4 thrice aluminium sulfate 18H2O if its molar mass is 6666 gram. So now we have to find the number of molecules of water in 333 grams of this compound. So in this particular compound, you know that in one molecule, if you take 18 number of your water molecules are there. So in 1 moles, how much it will be? 18 into Na. Then in 33 grams, how much it will be? It will be simply N into Na into 18. So what is the number of moles? Given mass divided by molecular mass, Avogadro's number, and your 18. So how much it will be? 3 1s are, 3 2s are 6, 2 9s are 18. So 9 into 6 into 10 raised to 23, option number B will be your correct option. Next question. 224 ml of NO2 at STP was liquefied. See, so 224 ml of NO2 is your volume of gas. So at STP it was liquefied and the density of liquid, they are saying. So of liquid is 2 gram per ml. Calculate the volume of and number of molecules in liquid. So volume they are asking, in the liquid how much it will be volume and how many number of molecules will be there. So as volume in gas is given at STP, you can first easily calculate number of molecules. How you can do? You know that number of molecules will be simply what? Number of moles into Avogadro's number. So how we will calculate number of moles now? Given volume 224 divided by how many volume at STP? 22,400 and into Avogadro's number is 6 into 10 raised to 23. So now it will be 100 and it will give us 10 raised to minus 2. 23 divided by minus 2 is 21. So it will be 6 into 10 raised to 21 molecules will be there. So in which option you have? Option number C. Clearly option number C was your correct option. You no need to have done further problem solving or calculation, but still we will do it now. So see here, as the ml is for your gas, Now density is for your liquid. So from density, you know that density is equal to mass divided by volume. So this mass of volume of liquid you can find from this formula. But for that you must need mass. How much mass was there? So you can calculate here. So as you know that your 1 mole of NO2 consists of your 22,400 ml. That means 46 gram of your nitrogen dioxide will consist of 22,400 ml. Then how much 224 ml will consist? So it will consist of your 0.46 gram. Correct? So now just substitute there. You will be getting your volume of liquid to be what? It will be your mass divided by density. So that is 0.46 divided by density is 2. So 2 2s are 4, 2 3s are 6, 0.23 ml you will be getting. So the correct option is option number C, 0.23 ml. Next question. The number of molecules in 500 ml of each oxygen, ammonia and carbon dioxide at STP are. As you can clearly see, volume is constant for every gas and at STP temperature and pressure is constant. So therefore, number of moles will be also equal for everyone. As number of moles equal, number of molecules will be equal. Correct? So number of molecules will be equal. Therefore, they are asked about molecules only. So it will be the same order. If you have asked atoms, then you could have considered it consists of 2 atoms, it consists of 4 and it consists of 3. So then the order might be NH3, then carbon dioxide and then oxygen. If they have asked about the atoms. Next question. Which of the following correctly represent 1800 gram of water they have asked? So see, you know that 18 gram of water consists of 1 mole of your water. So this contains Avogadro's number, Na number of water molecules, 6.023 into 10 raised to 23 molecules. Now 1800 grams of water they have given, obviously it is equal to your 100 moles. And if it is equal to 100 moles, then how many number of molecules will be there? Number of moles 10 raised to 2 into your Avogadro's number. So the correct option is E here. 50 moles wrong. 100 moles, yes, it is consist of 100 moles of water. No here, and here 10 raised to 23 plus 2, 25. So correct. So option number 2 and 4. So therefore option C is correct. Next question. Consider the following reaction. We have to consider this particular reaction and they have asked how many grams of HCl will react with 5 grams of manganese dioxide. So see, you can clearly see from this particular equation that your 1 mole of manganese dioxide require 4 moles of your HCl. That means 87 grams of manganese dioxide require 4 into 36.5 grams of HCl. Then 5 grams of manganese dioxide will require how many grams of HCl? So simply your X will be what? X will be 5 into 4 into 36.5 divided by 87. So it will give you how much? 8.4 grams. So the correct option will be option number C. Next question. Consider element A and B. So A has atomic mass, atomic weight 12 and B has 35.5. A and B combines to form a compound X. So if 2 moles of B combines with 1 mole of A, so how many moles of B and how many moles of A in one molecule? So that for A, B2 is your molecular formula. Then the weight of 1 mole of X, 1 mole of X will be equal to summation of your atomic masses of elements present there. So A is having 12 and B is having 35.5. Therefore 2 into 35.5, it will be giving you 83. So the correct option will be option number B. Next question. The law of conservation of mass can be explained by which of the following statements? So we have to explain law of conservation of mass. It talks about your summation of mass of your reactants will be equal to summation of mass of your products. So this, if it is explained with respect to your mass and the mass is given and it is proved, then you will say that will explain your conservation of mass, not just by statement. So see, 100 gram of water is heated to give steam. But how much steam we have obtained, that we have to know. A sample of nitrogen gas is heated at constant pressure without any change in its mass. So a change in mass has not occurred, but still mass we have to mention. if 36 gram of carbon combines with 32 grams of oxygen to form 68 grams. So here mass of reactants is equal to 68 and it will giving you 68 grams of carbon dioxide. So option C is clearly correct option. Next up, a sample of calcium carbonate has the following percentage composition: calcium 40%, carbon 12% and oxygen 48%. If the law of constant proportion is true, then the weight of carbon in 2 grams of calcium carbonate sample will be water. So you can clearly say they are asking about if there is a 2 grams of calcium carbonate, then how many grams of carbon will be there. Now from given, you go with the carbon percentage. So in 100 grams of your calcium carbonate, they are saying 12 grams of carbons will be present. So then what will be the value of X simply? So X will be equal to 2 into 12 divided by 100. So it is equal to 24 divided by 100. So it is 0.24 grams. So correct option will be option number B. Next question. The following data are obtained when dinitrogen and dioxygen react together to form different compounds. So different compounds are formed using nitrogen and oxygen as a sole element. So now there is a proportion of mass will be different, but the elements are same. So law of multiple proportion can be applied, but still we have to see whether it is working or not. We are getting a ratio or not. So what you can do is, you can consider any of these oxygen or dinitrogen. Take constant mass. So here there is 28, 28. I will consider this also 28. Multiply by 2. If I multiply this by 2, this will also get multiplied. So here it will be 16 2s are 32, 64, 80 and 60. So what is the ratio? 16 1s are, 16 2s are, 16 4s are, 16 5s are. So it will be 2:4:5:1. So are we having a simple multiple ratio of oxygen present in your nitrogen mass? Correct. So therefore law of multiple proportion. Next question. 52 unified mass of helium contains how many number of atoms? So see, whenever you are defining mass in terms of unified mass, it is talking about your one atom only. So if you say 4 unified mass of your helium atom, then it tells about 1 atom of helium mass. So 1 atom of helium it will correspond to. If you talk about 4 grams of helium, then it corresponds to how many atoms? Any atoms. Understand the thing separately. But here unified mass. Therefore, for 52 unified mass of helium will consist of how many atoms? It will be just 52 divided by 4, which will be equal to 30. So correct option will be your option number B. Next question. Which of the following is the correct order of your increasing weight? We have to compare the weight here. So now here, first here let us take a, what they have given? 0.625 grams of your iron. So already they have given you weight. For next one, they have given 0.0105 in equivalent of H2C2O4 2H2O. So equivalent can be converted into grams. How? You have to write equivalent and equivalent weight. So what will be the equivalent weight? Molecular mass divided by your valency. There are 2 replaceable hydrogen. Valency is 2. Molecular mass will be equal to 126. So now it will correspond to 0.66 grams. Next, if you take this one, that is your zinc. So 6.10 raised to 21 atoms are there, it is saying. So you know that 6 into 10 raised to 23 atoms will present in 1 mole, that is 108 sorry. It will be present in 1 mole of zinc. Correct? Then 601 into 10 raised to 21 gram will be containing how many moles we have to calculate. So rather than taking mole, what we can do is we can take this directly into the mass. So you can write 6 into 10 raised to 23 consists of your 1 mole of your zinc consists of how much mass? So mass it will be 65. So now 65. So 6 into 10 raised to 21 will consist of X. Now X value comes around 0.647. Now let us talk about your silver which is given here. So here carefully see gram atom is given. So you know that 1 gram atom is equal to 1 mole. Correct? So therefore, 1 gram atom of your silver will consist of 108 gram. So 6 gram atom of silver will consist of how many grams? So X will come around 0.648 grams. So now if you consider the mass, which one will be having the highest mass here? 0.66. It is the highest. So first one, this one, and where you have another option where it is the highest one, no option. So option number B is clearly the winner. And next it is your 0.648, that is of your silver, then zinc, and then comes your iron. Next question. Which of the following contains the highest number of atoms they have asked? So how you will calculate number of atoms? So number of atoms can be calculated by number of moles, Avogadro's number, into number of atoms present in a molecule. Correct? So number of moles can be written as weight divided by molecular mass into Na, into number of atoms. If you carefully observe here mass is given as a constant. So now you will just consider the ratio of your number of atoms divided by molar mass, and Na will be a constant just. Okay. So write the ratio for each of the following cases. So for first one, what will be the ratio? Here it is number of atoms is having 14, and what is the molecular mass? 58. For second one, what is the molecular mass? 28, and how many atoms? There are 2 atoms. And in the next case, how many molar mass? 108. How many atoms? 1 atom. Molar mass 18. How many atoms? 3. So now if you take the ratio here, it will come around 14, 4 point something it will come. And here 2 ones are 2, 2 fours are 8, 14 it will come. And here 3 ones are 3, 3 ones are 3, 3 fours are 12, 15, this is the 18, 6. So now which one is having the least denominator having the most value? Correct? So least denominator is for first option, so therefore its number will be very high. So option number E will be your correct option. Next, if 0.8 mole of carbohydrate with empirical formula CH2O has 10 grams of hydrogen, then molecular formula of carbohydrate will be water. So clearly see, we know that here in which empirical formula CH2O has 10 gram of hydrogen, then molecular formula of carbohydrate will be what they are asking. So here you have 0.8 mole of, let's say, empirical molecular formula to be N times, has how many grams of hydrogen? 10 grams of your hydrogen. Then for 1 mole of your carbohydrate, how many grams of your hydrogen you will be obtaining? That you have to find. So what the value will be? So the value will be, X value will be 10 divided by 0.8. Correct? So 10 divided by 0.8 gives you approximately 12 value. So now 12 gram of hydrogen is present in 1 mole of your CH2OH. So now let us take just the number of empirical formula and molecular formula mass to calculate N value. So N will be in molecular formula, what is the mass of hydrogen? 12. In empirical formula, what is the mass of hydrogen? 2. So it will give you 6. So here it will be 6. Therefore, C6H12O6. So option number A will be your correct option. Next question. In 2.8 liters of a diatomic gas. So diatomic gas means your number of atoms will be equal to 2. At STP, the number of molecules and atoms respectively, or they have asked. So see, you know that 22.4 liter consists of your molecules. So if it is consist of Na molecules and it is diatomic, the number of atoms will be 2 Na. Correct? So now the given volume is here 2.8 liters. Then 2.8 liters consist of, let's say, X molecule. Then what will be the number of atoms? 2X. Correct? So let us find the first value of X. X will be simply what? It will be 2.8 into Na divided by 22.4. Correct? So if you take 1 unit at that side, so you will be getting what? 2 ones are, and here it will be 2 eights are. So 1 divided by 8 Na, it will be giving 0.75 into 10 raised to 23. So how much it will be? 7.5 into 10 raised to 22. So now what will be the mass of number of atoms here? 7.5 into 2. Therefore 15 into 10 raised to 22. So the correct option will be clearly option number C. Next question. The density of the liquid's density is 1.2 gram per ml. If there are 35 drops in 2 ml, then the number of molecules in 1 drop will be water. So to calculate this, what we have to do? First, you know that density is nothing but is equal to mass divided by volume. Correct? So you know the density, and if you know the volume, you would know the mass. Correct? Then you just divide how many number of molecules. How will you calculate it? You will be calculating it by number of moles into your Na. So it will be just weight divided by molecular mass into Na. So for that weight you need. So to calculate weight mass you need the volume. So how you will do? See here. So if 35 drops corresponds to 2 ml, then 1 drops corresponds to how many ml? So here X value comes around 2 divided by 35 ml. Now you got volume. So you substitute in this formula, what will be the mass now? So here mass will be equal to density into volume divided by molar mass into Na. So density is 1.2, volume is 2 divided by 35 and molar mass is given 70 into Na. So 2 ones are 2 35s are. So you can clearly say 1.2 divided by 35 whole square Na. So the correct option will be your option number C. Next question. An element X is found to combine with oxygen. So there is an element X, it is combining with oxygen to form a compound with the molecular formula X4O6. Now they are saying if 8 grams of element combine with 6 gram of oxygen, what is the atomic weight? So what they have given, 8 grams of X combines with what? 6 grams of oxygen. Correct? Now, if you carefully see this molecular formula, you know that 4 into atomic mass of your X combines with how many grams of oxygen? So 6 into 16 grams of your oxygen. Correct? So you can clearly calculate the value of atomic mass from here. So what will it will be? So atomic mass of X will be equal to 8 into 6 into 16 divided by 6 into 4. Correct? 4 are 4 2s are 8, 6 cancel, 16 2s are 32. So therefore option is B. Next question. The maximum number of molecules is present in which of the following options? So the maximum number of molecules they have asked. So how will calculate number of molecules? Number of moles into Na, correct? So number of moles, how will calculate? It will be either equal to weight divided by molecular mass. If it is in gas at STP, it will be given volume divided by 22.4 liter into Na. Just do it. So here in the first case, what you will do? You will take 15 divided by 22.4 liter ratio. In this case, 5 divided by 22.4 liter. And in this case, 0.5 divided by, what is the mass of hydrogen? 2. And in this case, you will be taking 10 divided by 16 2s are 32. Correct? So now, what is the mass you will be getting here? So the for first case, so first is 15 divided by 22.4. So here you will be getting mass as to be 0.6. And here you will be getting, it will be equal to 1 divided by 4, 0.25. And here also you will be getting 0.25. And here if you take approximately the 30 and it will be 100 divided by 3, 0.33. So which is having the highest number of moles? Option number A. So option number A will be your correct option. Next question. If Na is Avogadro's number, then what will be the number of valence electron present in 4.2 gram of your nitride ion? So let us consider this nitride ion. They are talking about 4.2 gram of nitride ion. Valence electron, how much it will be? So it will be just number of moles into Avogadro's number into what you will be doing? You will be doing number of electrons in your valence shell. So number of moles, how much it will be? Given mass 4.2 and what is the molecular mass of your nitrogen? 14. Now what is the number of valence electrons present in your nitride? So valence electron here 5 and there is minus 3 charge, so 8. So 8 into Na. Correct. And what will be the value now? Here it will be giving you 2.4 Na. So correct option will be your option number B. Okay. Next, the 1 ml of N2O at STP contains how much? So 1 ml of N2O they are asking, and they have given answer in terms of atoms, electrons and molecules. Correct? So how I will calculate? See. So your 22,400 ml consists of your Na number of your molecules, and how many atoms it will be there? So 3 into Na number of atoms, and how many electrons will be there? So if you take here nitrogen consists of 7, 7 are 7 to the 14, and 14 plus 8 22. So 22 into Na electrons will be there. So just you do for each case. So now what will be the number of molecules now? So 1 ml divided by 22,400 into your 6 into 10 raised to 23. Correct? So this option is given, molecules is correct? Yes, it is correct. Next, here it will be 1 ml divided by 22,400 ml into 3 into 6 into 10 raised to 23. 6 on the 6 is 18 and here 22.4. So you can write 1 divided by 224 into your 10 raised to 22. So is it correct given? Yes, it is correct. Now for this case, how much it will be? 21 divided by 22,400 into 22 into 6 into 10 raised to 23. So how much it will be? 132 divided by 2 to 400 into 10 raised to 23, and now decimal point to 13.2, 22.4. Correct? So option number C is also correct. So therefore all of these are your correct option. Next question. An impure sample of silver. So there is a sample of silver here which is an impure. So how much gram you have taken? 1.5 gram. Is heated with sulfur to form 0.12 grams of your Ag2S. Okay. So silver is there. It is heated with sulfur and you are getting Ag2S. So 2 moles of Ag is used. What was the percentage yield of your Ag2S? Here they have been asked you. So what you can do here is, so first let us initially understand what must be the your yield. Okay. So what will be the yield according to you? So here a impure sample of 1.5 gram of silver is taken to form how much they are saying? 0.12 gram. So this is will not take. Let us identify for 1.5 gram how much gram of Ag2S has to initially form. So from this particular equation you can clearly say that 2 moles of silver, 2 into 108 grams of silver must give 1 mole of Ag2S. That is 248 gram of your Ag2S it must be giving. So then what will be the value of X? So from this following equation the value of X will be 1.5 into 248 divided by 2 into 108. Correct? So 2 into 108 it will be giving you 0.12 something. Correct? 2 ones are 2 twos are 2 fours are 8, 124 it will be giving, and it will be giving you 0.12. Now 0.12 you have got. Now it was sorry. So here the mass of X will be equal to 1.5 into 248 divided by 2 into 108. So how much mass you should have got? 2.6 gram you should have got. So this is the actual mass you should have get. Well, how much you have got? 0.12 you have got. So then percentage yield will be simply how much you have got actually and how much actually you should have get into 100. So it will give you around your 6% nearest value. So 6% nearest value for which one you are having? You are having for your option number B. Next question. A mineral has the following composition. So you have a mineral which consists of your magnesium oxide, silicon dioxide and water. With how many percentage they have given? So with 31.88 percentage, 63.37 percentage and 4.75 percentage. Then the empirical formula of compound will be what they have asked. So for that, let us identify the least ratio. Therefore 31.88 divided by, here you will be doing 24 and 16, 24 plus 16. Next, here if you take 63.37 divided by silicon is 28 and oxygen 60, 16 2s are 32 and it will be giving you 60. And water if you take 4.75 divided by 18. So how much value will be getting? So for first case you will be getting around 0.79 and for the second case 63 divided by 37 you can clearly say it will be giving you 1 point something 05 and for 4.75 divided by 18 it will be giving you around your 0.26 something. So the least ratio will be 3, 4 and 1. Correct? So 0.26 I will divide by each case. So here you can see the empirical formula. Least formula will be like this. MgO thrice, SiO2 4 times and H2O is 1 time. So you can say Mg is 3. How many hydrogen are present? Hydrogen is 2, H2. Then magnesium how much? 3. Next silicon how much? 4. Oxygen how much? 4 2s are 8, 9, 10, 11, 12. So correct option will be your option number D. Next question. The minimum amount of oxygen consumed per atom of your reactant in which of the following reaction? So they have asked about minimum oxygen where it will be consumed. So in all the cases you can clearly see here. So what you are seeing, 4 moles of see. For one thing I will do and next we will find the least ratio. Okay. So for this one, 4 moles of iron required, 3 moles of your oxygen. So 4 moles of iron means 4 into 56 gram of your iron requires how many moles of your oxygen? Actually requiring your 3 into 32 grams of your oxygen. Correct? So the minimum oxygen consumed per gram of reactant they have asked. So for 1 gram, how many it will be there? So here the least ratio you can find in terms of just X will be equal to 3 into 32 grams of oxygen required divided by how many grams of iron you have taken. So for every case if you do this ratio you will be getting. So now for option B just move directly. So how many grams of oxygen here? 32. So how many grams of magnesium here? 2 into 24. And in next case, how many grams of oxygen is present here? 5 into 32. How many grams of phosphorus is present? 31 into 4. Next in this case, how many grams of oxygen? 5 into 32. Next, what is the mass of C3H8? So carbon is 12, 24 plus here 8. Correct? So now if we talk the least ratio here, so here 32 you are getting. So if you divide it by 1, 3 ones are 3, 1 carry here 5, 15 point something you will be getting. So here 32 divided by 4 into 15 you are getting. So in this case what you are getting here? So 5, 6 are 30 around something, 6 point something will be there. Now here 32 is there similarly and here if you take it is 32, 54 plus 8 you will be getting around 32 divided by 6 or something you will be getting. So now you can clearly see that which is having the highest denominator that will be having the lowest value of your oxygen. So highest denominator is for what? 15 into 4, 6 into 4 or 6 or 2 into 24. Which one is having your highest value of your denominator? Obviously first case. So option number A will be your correct option. Next question. Which of the following statement is incorrect? They have asked. Gram atomic mass of an element may be defined as the mass of Avogadro's number of atoms. Yes, when we are saying gram atomic mass, it is talking about 1 mole of your compound. And 1 mole of your compound nothing but your Avogadro's number. The molecular mass of diatomic elementary gas is twice its atomic mass. Yes, it will be 2 into atomic mass twice. So Gay-Lussac's law chemical combination is valid for all substance? No, it is not valid for all substance. It is valid for only your gases. Next, a pure compound has always a fixed proportion of mass of its constituent. Yes, it has a fixed proportion of your mass. So option C is your wrong option. Next question. What is the molarity of H2SO4 solution that has a density of 2.84 gram of Cc? So that density is given that of your solution and the weight is given by 98% by weight. So if 98% by weight is given, you can clearly say that 98 grams of H2SO4 in your 100 gram of your solution. So we have to calculate molarity, correct? So molarity will be equal to what? Number of moles divided by volume in a liter. We have to find now volume, correct? So you got number of moles to be 98 grams and molecular mass 98 into volume we need. So from density you can get volume, that is mass divided by volume. So what is the mass here? Volume will be equal to, mass is 100 grams for solution. So 100. What is the density given? 2.84. Correct? So it will be equal to here 100 multiplied by 2.84 and it is in ml. So that's why you will multiply by 1000 again. So here 2020 got cancelled and here 98 got cancelled. You will be getting 28.4 molar. So correct option will be your option number C. Next question. Among the following pairs of compound, the law of multiple proportion is illustrated by. For law of multiple proportion, only two types of element must be there but in different mass ratio. Correct? So here H2S, hydrogen, sulfur and oxygen, three types of there. Nothing, it is not possible. Then beryllium, oxygen and fluorine, three are there. No. Nitrogen, hydrogen and oxygen, three are there. No. Nitrogen, oxygen, different ratio, option number D. Next question. Assertion. 1 mole of sulfur dioxide contains same number of molecules present in 1 mole of oxygen. So they are saying if 1 mole of sulfur dioxide of any gas you are taking, then the number of molecules present in 1 mole of same oxygen will be same. Yes. If number of moles same, number of molecules will also be same. Assertion is true. Molecular weight of your sulfur dioxide is 2 times that of your oxygen. So molecular weight of your sulfur, if you calculate 32 plus 16 2s are 32, it will be, and here that is 2 times of it is 32. Correct? So here if it is 64 and it is 32, it is saying that it is 2 times of your mass of oxygen. Yes, obviously it is true. But is it the reason for your assertion? For same number of molecules? No. If number of moles is same, then number of molecules are equal. That has to be explained in the case of reason. So you will say both assertion and reason are true, but reason is not the correct explanation of your assertion. Next question. Use the data given in the following table to calculate molar mass of naturally occurring argon. So naturally occurring argon is there. This question is very simple. You know that how you will calculate percentage abundance into your molar mass. You will calculate summation and divided by 100 you will do. Correct? But in this case, what you can do here in examination is first see the options which I have given. So if options are far apart, so they are far apart, and now see the table. So now see the percentage. Which one is having the highest percentage? So here you can see 99% of something is 39.9 grams of isotopes only. So obviously the mass will be nearest to this value. So it will be obviously option number B. Okay. So the next question. Next question. 40% of volume weight divided by volume of NaCl. So that means 40 grams of NaCl is present in what? 100 ml of your solution. Okay. So the specific gravity is 1.20 is equivalent to water. So they have asked about your ppm. So for ppm, how you can do is parts of your solute divided by your solution part you will take and then you will multiply by 10 to the power of 6. So solution you can get from your specific gravity, that will give you mass of solution to be your volume of your solution into your specific gravity. You have to take 1.20. So it will be 100 into 1.20. You will be getting 112. So here if you substitute, what you will be getting? 40 divided by 112 into 10 raised to 6. You will be getting here 0.35 So it will be 3.5 into 10 raised to 5 ppm. So the correct option will be 10 raised to 5 ppm, option number A. So I hope you have understood all the solutions. So practice well. All the best. Thank you.